Okay, now that we did some examples on lines with two intercepts, I think it's a good time to start with lines with only one intercept. So a regular equation that we already looked at was y equals to 2x plus 1. So we know that we can set up values of x equals 0 to find the y-intercept, and then y equals 0 to find the x-intercept. And we know that the line is going to cross those axes at two different points. So this one would actually look like this. How about some equation that looks like y equals to 2x? It is not so obvious, but in this case, it is going to be a unique point at which that line crosses both axes. So for example, if we wanted to find the y-intercept, we set x equals to 0, and then by plugging in the value, we find that y is also equal to 0, which means that the line is crossing the origin. Now to find the x-intercept, we make y equals 0, we plug that value in and then solve for x, but then we find, hang on a minute, x is also 0, so the 2 points that we find are actually the exact same point. And that's totally fine. What that's telling us is that this particular line, or this particular equation, is going to be a straight line that crosses the origin. And basically what's going to happen, it's going to look something like this. Okay, and the reason I know that is because the coefficient attached to x is positive. So we know that if we put a disk here, it's going to roll in that direction to the left. Now, how could I tell that? Well, basically what's happening here is that even though we're finding both y and x intercepts, it turns out that the origin is a point that is shared between the two axes. So it's totally fine to have this kind of situation. And in fact, a lot of lines look like this. So whenever you see an equation that looks like this, where there's no constant term on the side, like this one, you immediately know that this line is going to cross the origin. And then obviously, if you want to find out the actual steepness of that particular line, you have to select a few other values of x in order to calculate that. So for example, in this case, we could choose something like x equals to 1, and then y would be equal to 2. So that point 1, 2 would also lie on the line. So we would have something like 1 and 2 here. So basically, by looking at that, we can tell from this line that as you move 1 unit to the right on the x-axis, you're moving 2 units up on the y-axis. So it's a 2-to-1 ratio in terms of vertical movement compared to horizontal movement. So that's the main difference. Now, is that the only kind of line that you can have that only has one intercept though? Because I could draw something similar. I could draw something that looks like this. So let's draw the Cartesian plane again. And I could select a point here, let's call it point 3. And I could easily draw a line that goes through that point, but does not go through any other point here. So it's a straight line that is horizontal, which means that it is parallel to the x-axis. So it is never going to cross the x-axis here. So, and the interesting thing is that you notice that this has no slope. So there's no steepness, which means that if you put a disk here, it is not going to roll anywhere unless you push it to one side. But then, again, it's not really going to fall by itself. So how would we represent the equation of a line like this? Well, it turns out that the only type of equation that would satisfy all those points that are basically y equals to 3 is just, as you guessed it, y equals to 3. Because what this is telling you is that for no matter what value of x you choose, the value of y will always be 3. That's what this equation is telling you. So this is what we will call the equation of that line. In a similar manner, if I drew something that looks like this, so it would be a completely vertical line at the point, say, point 2, then what do you think would be the equation of the line? I mean, all the points that lie on this line are always going to lie on the point x equals to 2. So basically, the line of that equation will be x equals to 2. Because it doesn't matter what value of y we choose. The value of that point is always going to lie on x equals to 2. So I guess that's the main point that we need to always make with this kind of equation. So those are the 3 types of equations that you can have that only have one intercept, because they only cross one of the axes or they cross both of the axes but at the exact same point. Alright, so in the next video we're going to do some more examples on this, and hopefully that way you will know everything there is to know about drawing straight lines on the Cartesian plane.